there are two curves here, and if I take the 2 points in between on the curves, this is the curve. Let me take y equal to f2x, and this is y equal to f1x. This is f1x curve. Okay, and if I take A, B, C, D points, A, B, C and D point, this is M and this is N point, this is x-axis, origin O, by dash axis, S dash axis. So the area in between these two curves is given by, if we take again a strip here, and this strip is of this kind, delta x. Okay, we take P and Q points here again, and if I further draw perpendicular to the x-axis, M and N. Okay, in the same way, just we have to put the formula here. The area between these two curves, this curve and that curve, will be, so area between two curves will be equal to limits here a to b. If I take first is f1x, the upper curve here, this is dx, minus again a to b limits, this is f2x into dx. This is the area between the two curves by formula of single integration. This is given by single integration here. Or we can take a to b common, the limits, this is f1x minus f2x ds, completely ds. So limits then applied. Okay, after integration we will apply the limits. So this is the process of finding the area between two curves here. The upper curve is first and lower curve is after that. This is what you call area between two curves. The formula we have to find out like this. Now, second thing, that by double integration. Let me talk about how to find out area between x-axis, the curve, and the two ordinates with the help of double integration. Okay, so that is next process. Let me talk about and double integration. Okay, so if double integration is to be used, double integration, this we have talked in multiple integral or multiple integration. Double integration, this is the fourth point I think I'm discussing over here. Fourth point here, double integration. With the help of double integration, how the area is to be calculated. So area of a curve, between, this is between the curve x-axis and the two ordinates, x equal to a and x equal to b, the two ordinates here. So what we do? Okay, so this is, let me take the curve here, or we can take the curve not like this, and take the continuous curve like this. With the help of double integration, this is again a, b, this c, d. Okay, so this, if this is whole divided into smaller strips, this whole area of A, B, C, D is divided into smaller strips, and I think this we have done in the multiple integration, and then this is divided into smaller curves like this. So smaller elements which we have obtained, if we choose one element, Okay, and if I suppose this is P and this is Q, P x y, this is Q x plus delta x by plus delta y coordinates, and then if I take this middle element of this, so this distance will be delta x, this is delta y. So area of this smaller element will be area of the smaller element. The smaller element is equal to delta x delta y. This is the area here. If we apply the limits, okay, so then apply the limits here. So what is the area in these two curves? Area of the plane curve between the x-axis of x, the plane, this is under the plane here, between x-axis, this is x-axis here, y dash axis, x-axis, and this is the total area we have to find out. So area of the plane between the axis of x, the plane, and the ordinates x equal to a, and the ordinates x equal to a and x equal to b. So how do we find out? This is the smaller area. We apply the limits here, and what are the limits for x variable? Limits are a to b. This is x equal to a here. Here it is x equal to b. Now this is the smaller element here. For this, y will be y equal to 0 from this point to upper point, and here y equal to fx. That area is given. That curve is y equal to fx. Curve is y equal to fx here. Okay. In that way, we can apply y equal to fx. Therefore, area of the plane curve ABCD of the area of the figure. Let me take figure here. Of the figure ABCD is given by, this is first limit a to b, x equal to a to x equal to b. Second integration sign for y, this is y equal to 0 on the x-axis to y. Here is the curve given, y equal to fx into dx dy. Limiting portion delta x delta y will convert into dx dy. So this is the area of this plane curve with the help of double integration. This formula we use by double integration. Okay, and if there are two curves in this case, if with the help of double integration, area between two curves we have to find out. Let me put the formula for that also. And what is the formula we have to apply for double integration in case of two curves? So area between two curves, let me take. Now area between two curves, area between two curves. This is fifth topic, I think. Fifth or sixth topic, no problem. This is the fifth topic. Area between two curves. What is the area between two curves? Let me talk about that. With the help of double integration. With double integration. With the help of double integration. We have to apply the double integration then. Okay, so similarly the double integration, just say, for example, this, and these are two curves. This is y equal to f2x, here y equal to f1x. Okay, and this we have taken here. Again, m and x-axis, o y dash axis, This is A point we have taken. This is B point, C, and the D point I have taken. Again, divided into strips, different, okay, smaller strips we have to divide it into, and so on. Then one of the strips we have to select, and suppose this I have selected this smaller one, which is area of which is delta x, delta y, this delta x, this delta y. PQ point we have selected, okay, from the curve, upper curve. So between these two curves, this is y equal to f2x. Simply we have put the formula here. Double integration sign area is given by, and x, again x equal to a, x equal to b. But for y, we have to select the lower curve, which is f2x, y equal to here, here y equal to f1x, and dx dy. This is the formula for area between two curves, f1x and f2x. Then by limits we have to put at f2x to f1x, because f1x is bigger than f2x. So this is, and x limits are x equal to a to b. Here x equal to a, this distance is a here, small a, and this is b up to this point. So this is y equal to, sorry, x equal to b, and here x equal to a. So between a to b and these two curves, so this is the formula we have to apply. Okay, this is in case of double integration. Alright, we have applied this formula. We will apply in case of double integration. Double integration is also, or can also be used to find out the area of a curve, of a plane curve. Okay, if there is any process of this, I mean, in clarification, if there is any mistake or anything, please ask me so that I can clarify that again. So now let me talk about questions. Now questions one by one. Let me talk about first question. How do we find out area of plane curve? Now tracing of the curve, which we did in the previous lecture series, and sometimes they have asked that find the area, first trace the curve and then find the area. We will find out the area here. Okay, so first question, let me talk. Find the area bounded by the parabola y square equal to 4ax and its latest rectum. Okay, question number 1. Area between the parabola, the curve is here, the parabola y square equal to 4ax, it says, so y equal to 4ax is the parabola here. If I take, this is the parabola, x-axis O, y-axis, y dash axis, this is x-axis. Why? Because this is symmetric about x-axis. Y is even power, so the curve will be symmetric about x-axis. So how to trace this? The curve is symmetric about x-axis, as y is even power, as y is even power of y is even, so therefore the curve will be symmetric to x-axis, because y will be double value negative and positive. For every value of x or positive value of x, y square will be positive or negative. Okay, this is what, if I take x negative, but that cannot be taken because beyond 0, 0, because and it is passing through the origin. Why? Because there is no independent term. Second point is, it will pass through the origin. It will pass through the origin. As no independent constant term. Constant term is not there. Any independent constant term is not there. It will pass through the origin. Now, second point says that find the area of this parabola between the and its latest rectum. latest rectum, let me take this, its latest rectum is this at x equal to a. So at x equal to a, from this equation we find out, dividing by 4 here, so a is obtained. X equal to a is the latest rectum from this point to this point. So this is a0. Let me take latest rectum L and L dash. This is a point. Let me take. Okay, so if I take a small strip in between, so area, this whole area we have to find out. And if I find out area OAL, this area upper one, and make twice of that, twice of area OAL will give us the total area. This is a strip, let me take P, and this is Q, this is M, this is N, and this distance is delta x. This is delta x here. Okay, so again delta x, this is in limiting position of, because Q is x plus delta x by plus delta y. This point is x plus delta x by plus delta y, and P is x by, with this distance delta x. So what is the area of this plane curve? Therefore area solution here we are finding out, and this we have already discussed about that the curve is symmetric about x-axis passing through the origin. Okay, beyond, because for negative value y square is negative, so beyond 0 there is no any, okay, curve does not exist beyond 0 0. Beyond 0 0 on the negative side of, or on the negative x-axis, okay, beyond the origin the curve will not exist, because y square will be negative for x negative. Okay, so this is another point. The curve is passing to the origin, this is there, and meeting x-axis at a. Why? If I put here 4ax equal to 0, at x equal to 0, y origin is the y is the tangent line, or y-axis is the tangent line in this case. Okay, so that is the point here. Second point, that for every negative value of x, the curve is, the y square is negative, curve will not exist between, beyond, or for negative value of x. For negative value of x, curve is not existing. The area, let me first find what the equation of the latest rectum here. Equation of the latest rectum is x equal to a. X equal to a. So twice a. This x equal to a. This L A L dash is the latest rectum. Equation of this is x equal to a. Latest rectum is this. Okay. So if I find out the area of the whole parabola between latest rectum and parabola, area, therefore area of the parabola and its latest rectum, between its latest rectum and its latest rectum, area of the parabola and its latest rectum, between its latest rectum, area between its latest rectum and parabola, latest rectum and parabola, can be written as twice into area of figure OAL. OAL, this upper, and twice of that area if we calculate. So this twice into, with the help of single integration, 0 to, this is 0, here x0, here x equal to a, 0 to a limits, and this is y into dx. Y into dx, for this is between x-axis and this parabola, so y into dx. So the value of y from the given equation, here y is equal to under root of 4ax plus minus, but plus we will take because this is twice under root ax. The value is value y here 0 to a, this is 2 under root a into x into dx. Okay, now let me further solve it. Finally solve it. So this value will be, okay, so area is given as 4, 2 into 2, 4, 4 into 0 to a, this is under root a also, will come out, because under root a we can take outside, and x is here, under root, that means half power into dx. This is 4 under root a, limits is here 0 to a, okay, 0 to a limits, which is here, 0 to a limits, and twice of that, so under root a we have taken outside, only under root x, that means now integration, after integration this is x is over 3 by 2, because plus 1, that means 3 by 2 divided by 3 by 2, integration, limit 0 to a. If I put a here, a will be, and this is, sorry, under root a also, a half power outside. This is 4 to the 8, 8 by 3, a power half, and from this inside we will get a raised power 3 by 2 also, because that upper limit a, if I substitute the value of x, the variable x is replaced by a upper limit, a raised power 3 by 2 this is, and a half, it will give us 8 by 3, a 4 by 2, that means a square. 8 by 3 a square is the area, is the answer here. Area of this, because twice we have to do, twice of this figure will give us the total area of the parabola and its lattice rectum. So the area bounded by the parabola and its lattice rectum. Okay, bounded by parabola and its lattice rectum. This area is there. This is the final answer. Question number 1 we have done. Okay, so question number 1. After solving this question, let me take the second question here. Just we have to, sometimes there is no requirement of the figure, just find the area with the help of formula in case of integration, first integration or second integration. Here also second integration could be done, not a problem. Okay, it could be done by the help of second integration, twice of, okay, double integration. If I put, then the limits will be, okay, dx dy, and put the limit of for y as 0 to, because on the axis of x, y is 0, 0 to fx, 0 to fx, then curve fx is y here. So y, the value of y we have to substitute then, which is already there. That is the same question, no problem at all. I mean, we could do this 0 to a, x limits. For y it was 0 to fx or y only. 0 to y or y equal to fx. Pi limit, this is dx dy. Then this is 0 to a. If I integrate this with respect to y first, so it will be y into dx now. Limits 0 to fx. 0 to a. Here it is y, that means fx here. What is fx? The formula or value of y here. That value of y is the same thing. Under root that, so this is twice, sorry, twice of area. This is twice of 2 under root ax, because fx is or y is into dx. The same thing, 4 under root a, we have taken outside 0 to a, under root x, integrated with respect to x now. Here it was dx dy. After integration with respect to y, we have obtained y into dx. Now put the value of y upper limit, this is fx, but fx is y square, sorry, y square, or y square is under root of this value. Fx is under root of, fx equal to y mean, so y is under root of that value. Similarly, same thing, after integration it will be x is 3 by 2 divided by 3 by 2, it will be 8 by 3a square, finally answer. So same answer is obtained. Okay, so either by double integration or single integration, answer must be same, or answer comes out to be same. This is question number first. We can apply either double integration or single integration we have to just know the answer, that what is the question answer must be same in both the cases. That is the quality of this. Now second question, let me talk about question number second. Says find the area of the ellipse this. Okay, question number second here. Sorry, so ellipse x square upon a square plus y square upon v square equal to 1. We have to find out the area of the ellipse this. We know that what is the ellipse? The figure of the ellipse, simply we know that this is the ellipse here. Let me draw on our own. This is the ellipse here. Okay, this is a point, coordinates are a0, this is x-axis, o, y dash axis, x dash axis, this is a dash point, this is b dash. Points here is 0 minus b, and here it is 0b. This is b and this is a here. Okay, so if I find out the area of one quarter here, this figure PQ again MN, this is delta x. This means width of this is delta x. Height P, coordinates are x by and x plus delta x, y plus delta y. And this height is y into delta x. Area is y into dx. Okay, so but this is one one quadrant of this. 4 times of this area of BOA, if area of BOA is made 4 times, then area of the whole ellipse will be calculated. Let me find out the solution. Here, area of the ellipse. Here, area of the ellipse is equal to 4 times area of the area of the quadrant. Let me take here quadrant. What is quadrant? BOA. Area of the quadrant BOA, and 4 times of that. That means 4 into. Now we have to find out what the value of y. This is limits here 0 to a again. 0 to a. Here 0 to b could also be taken as the limits. Or if we are calculating with y-axis and the curve, then limits are 0 to b. But in case of the major axis, x-axis here, so I have taken this as symmetric to both the axes. Now the curve is in between, even power of x and y. If I just describe the curve is symmetric to both the axes, because x square and y square both are even power. Curve is will not pass to the origin, because this one is independent curve, is not passing to the origin. Curve is symmetric to both the axes, x and y. Okay, so that is the point. And if I put y equal to 0, then x equal to plus minus a, x equal to plus a, and y equal to x equal to minus a. This is minus a0, and this is a0, and beyond a0 and y and minus a0, the curve will not exist. Reason is, if I put here this x something 1 minus this, if I put x greater than a, then it will be negative, because 1 minus bigger value. Okay, if x is greater than a, if I put, suppose this is twice a square. Twice a square means 4, or twice a square means 4a square upon a square. That means 3, 1 minus 3 is negative, y square will be negative. That is not possible. So curve will not exist beyond minus a and beyond plus a. Okay, because if I put minus a or plus a, more than minus a plus a, then the value will be negative. So y square will be negative. So curve will not exist beyond x equal to a and x equal to minus a. Similarly here, curve will not exist beyond, if I find value of x square equal to x square upon a square equal to 1 minus y square upon b square. So if I put y more than b or less than minus b, with minus 2b or plus 2b, etc., then also x square will be negative. Then the curve will not exist beyond this and beyond y equal to minus b. This is the description of the curve here. So curve, tracing of the curve is not required here. Only the area we have to find out. Sometimes they can ask that trace the curve and then find the area. That is required also, but in this case there is no requirement. We know that what the ellipse is. But if I describe the curve tracing method or procedure, then we can describe this, that beyond this point curve is not existing, beyond this point also not curve existing, because x square and y square negative in that situation. So that is the possibility. Okay, now next let me take y into dx here. So 4 into y into dx. This is the formula for finding out area. 4 into this area of the quadrant OAB or BOA. So BOA quadrant area is by dx. This is y into dx here. This is smaller area. Applying the limits, we will give this. So this is 4 times 0 to a. But here, let me solve it further. So here y square upon b square is equal to 1 minus x square upon a square, or a square minus x square. Alright. Is equal to y square b square, or upon a square here, or y square is equal to b square upon a square into a square minus x square. Y equal to plus minus, or this is b upon a under root a square minus x square. Okay, this is the point here. If I substitute this value, this is b upon a, value of y here, under root a square minus x square into dx. Now we know this directly from integration formula, or we can substitute x equal to a sin theta, etc., etc. We can solve it by that method also. So, but the final value will be, let me write the final answer of this question, because under root a square minus x square, we know that what is the integration of this. That shortcut formula let me apply. This is b upon a, let me take outside. In between, the integration of this is 1 upon 2 into x under root a square minus x square plus 1 upon 2a square into sine inverse x upon a, in this case x upon a. Okay, so this is the limit 0 to a. This is the direct formula of integral under root a square minus x square. What is the integration of that? Under root a square minus x square is 1.2x, here x, under root a square minus x square plus